We're now looking at problem 5 in Module 4. This problem is a full-blown simulation, a little bit more complicated than the one we had before, but not much really. We return to our familiar income statement. It's a bit more sophisticated. I've decided that we're going to have 3 uncertain elements in this simulation: sales in units, cost of goods sold, percentage, and variable cost percentage. Here's the probability distribution for sales in units. There's a 60% chance of 18,000, 25% chance of 22,000, and a 15% chance of 24,000. And this is in a horizontal format, unlike what we've seen before. And what we've got next to it is I've set up the same distribution on the vertical. So here's 60, 25%, 15%, all add up to 1, obviously. Here's my cumulative probability that I build for my discrete distributions, and here are my outcomes. And what I'm going to do is I add a random number here. Why? Well, because I'm going to be using a vertical lookup to take my RAND, which is U5, take it over here, look for a value, and return a value, and that value here is 18,000. So every time I recalculate the spreadsheet, I get a different value for the various uncertain events. You can see that changing as I change as I recalculate the spreadsheet. Here I've done what I've done in the past. Here's my RAND. Here's my function for my uniform distribution. It has the base of the low value and the RAND times the difference between the low value and the high value. Of course, if the RAND is 0, then it's the low value. If the RAND is 1, then it's the high value. So that's how we know that this is an appropriate linear function for determining the uniform distribution. Finally, we have a discrete distribution for the variable cost. Here we have the same thing. I return with a VLOOKUP using this RAND, looking at this table. The table is here. I find my value in the table and I return the outcome. And so all 3 random variables are determined and they're employed in the calculation of this net income. Of course, net income is the golden cell. It's the metric of interest, and we're going to generate 5,000 replications of that. We can see that table of values here. There are 5,000. Take my word for it. There are many values, and then from that we're going to create a frequency distribution or a risk profile. I calculate my summary statistics. Prob 5 dat is the area of all those 5,000 replicated experiments, the sample values. The mean is 32,584. We have a very high standard deviation, larger than the mean. We have a median that's higher than the mean in this particular case, a min and a max, and therefore an account of 5,000 simulated values. I create a set of bins on the basis of my min and my max, and then I do a frequency count with the frequency function as we've done before, and then I calculate a percent of the total for each of these values and a cumulative percentage, so I can ask these probability questions. The first question I ask is, given the results, what is the probability of a loss? 0 or less. So here's 0 or less. 18.6 is the value that I get here. I can replicate that value also by doing a count if in the Prob 5 data, the named range for my data. I will count the number of less than or equal to zeros and divide by 5,000. I get the same value. And then I did the same trick here as I did in problem 4. I'm interested in 70,000 or more, so I set this to 69,999, and I'm going to subtract 1 from that, which gives me 70,000 and above, and that's 13.62. And I also use the COUNTIF function to do the same, to replicate that value, and in fact I get the same thing. All right, that's problem number 5, and we are now done with all the Novice problems in Module 4.